Starting chapter 4, quadratics. So all this whole chapter we're splitting into two is quadratics. So when we talk about quadratics, we have a parabola. A parabola would be like a U-shaped graph. Okay, we have had a V-shaped graph, now we're doing with a U-shaped graph. So quadratic function in standard form looks like this. We'll get more into it. Vertex form looks like this. This should look familiar to you. This looks a lot like something we've seen before, except with absolute values here. Axis of symmetry is still the same thing. It's that dotted line that would separate the graph right in half that's going to be reflective on both sides. And the vertex of the parabola is going to be the same spot that you think about like the vertex of your absolute value, except it's not straight lines anymore, it's a U. So first, this right here, this is called a parent function. It might be a good idea to write parent over here. When you do this, you can do this two ways. You can make a table. If I plug in, I'm going to start at 0, and I'm going to do 1, -1, 2, -2. If I plug 1 into here, I get 1 out. If I plug 2 in, I get 4 out. -1 squared is 1, -2 squared is 4. You could do that, or you can go to your graph, go to y equals, plug it in, and then go second graph to get to your table, and then you can get these points here to plot your line. You should have at least 5 points on here. If you can't get 5 points, then I will know that, and we'll chit-chat about it. So plot 5 points. And your graph looks like this. Parent function, my vertex is at 0, 0, and this is what my typical function will look like. When I look at my domain, if I look to the left, it goes on forever, and on the right, it goes on forever. So that's going to be all real numbers. We can plug any number in for x. That's what domain means. We can plug any number in. My output, this is the lowest I will go, and the graph is above it, so y is going to be greater than or equal to 0, meaning that any number we put into this, the output is either going to be 0 or higher. I want you to pause the video and do this next one either by handwritten or in your graphing calculator. Graphs would look something like this. Now you may be making connection about something about this and what we've already talked about with our absolute values. My domain here is going to be all real numbers again, because any number we can plug in for x. My range here, it looks like y and 0 is the same type of thing, because this is the point of vertex. My y value here is 0. But now it's going below it, so y is going to be less than or equal to. Now when we're talking about my a value, there's 3 different things that could happen, and we've talked about this before. Either it's going to be, if this is my parent function, it could flip it, or reflection over the x-axis, could stretch it out, and that's what this graph did. It stretched out, it got skinnier, or it can compress or get wider, kind of pushed down. So now if we look at these next 2 graphs, again, I push y equals, I plugged into my calculator, I need to delete that out. Now if I go to my table, now I can look at my points. Now it looks like I'm gonna go here. I can look at a pattern on both sides, and I'm gonna plot these points right here. So this is what the graph looks like. So when I look at my translations or transformations, that's the same type of thing. For my parent function, you can flip over if you need to. It looks like my parent function moved down 5. So I'm gonna go down 5. You can also write down 5 if you want. There's just not enough room. My domain, looking on the left, looking on the right, goes on forever. So it's going to be all real numbers. You can go from negative infinity to infinity if you want. My range, again, this point for my y value is at -5. My graph is above it, so it's going to be greater than or equal to. So same type of thing for this next one. If I go to y equals, I'm going to clear that out. Now make sure that you have parentheses here. Oops, I want to get to the table and graph those points. So from my parent function, it looks like it shifted to the right. Look to the right, and it went 1, 2, 3, 4. That means say it moved to the right. 4, my domain, still all real numbers. That's a funny R. And again, my y value here is 0, because if I were to label this point, sometimes it will help people if you label the point. My y value is 0. My graph is above it, so greater than or equal to. So any output will be 0 or larger. I want you to do C and D by yourself right now. Here you should have got that this moved up 3. My domain still are real numbers since it's greater than 3 because the graph is moving up. Y is greater than or equal to 3. Here this moved to the left 1. So left 1, still all real numbers, and y is greater than 0. So kind of stuff that we have talked about before, asked with the absolute value, we can figure out all this information just by looking at my equation. So first, my vertex. If you haven't caught on yet, my vertex is going to be that transformation left and right and up and down. This would move it to the right 4. And if you're not sure, this would move it down 2. You can always graph it to check to make sure where that vertex is. I personally, when I look at this, I look at this 8 to see if it's pointing up or down. I like to just draw a sketch right over here so that I can remember what it kind of looks like. My axis of symmetry always goes through that line, through the vertex. My axis of symmetry is going to be at x equals 4 because it's going to be that line straight up and down. My maximum minimum, when I look at this point, my vertex here, that's the smallest I'm going to go. It'll be a min. When we're talking about max and min, it's the y value. So y equals -2 because that's the minimum it will go, and y is -2 because y moves up and down. The domain and range, if you haven't caught on, domain for these values are always going to be all real numbers because we're going all the way to the left, all the way to the right. My range, though, it always depends. It's going to be my y value because of this right here. And then I look, my graph is above that, so y is greater than or equal to. I want you to try to do b by yourself right now. So because of this negative, I sketch my graph and it's pointing down. My vertex, this moves to the left 1, up 4. That axis is with that x value. It's a maximum now because it's the highest value. And again, my y value is 4. All real numbers for domain, we can plug any number into this. However, the only numbers that we will ever get out are numbers that are less than 4. So my range is y is less than or equal to 4. And finally, if I'm looking at this, I can graph this. Now, first, before I do anything else, I can find my vertex. And this is where you might want to do this so that you know what numbers when you plug this into your calculator. So now I'm here, I'm going to go second graph to get to my table. So I want 1 to be kind of in the middle. Oh, I must have typed something in wrong. So I want 1 to be in the middle. So my vertex here is 1, 3. Now I'm going to plot these points on the left-hand and right-hand side of it. I should not have those there. It should look something like this. My domain, I go on forever on the left, go on forever on the right. My range, it's always going to deal with that y value because it's that vertex is the highest or the lowest. Right here, the graph is below it, so y is less than or equal to. Why don't you try to do b by yourself? And it should look something like this. So your vertex is moved left 2 and down 5. So when you look at your graphing calculator, that's where you want to focus on numbers on both sides of that. So it will help you plot your graph. You might have been able to see a pattern while you're plotting these points, and the more that you graph, you might be able to see that more often. But domains all around numbers, my y value here is -5, and the graph is moving above it, so y is getting larger than or equal to. And that's all we have for that. And have a great, grand, wonderful day.